Trillions of ghost particles are passing through your body right now, and you will never feel a single one. But what they are telling scientists about the universe is changing everything we thought we knew about the most violent places in the cosmos. These particles are called neutrinos. They have almost no mass, carry no electric charge, and interact so weakly with normal matter that they pass straight through the Earth as if it were not there. Every second, approximately 100 trillion solar neutrinos pass through your body. They come from the sun's core, from exploding stars, from colliding galaxies, and from processes in the early universe. You cannot stop them, detect them with ordinary equipment, or feel them in any way. So how do you study something that ignores everything? You build a detector the size of a cubic kilometer, bury it under a mile of Antarctic ice, and wait for the one neutrino in a trillion that occasionally bumps into an atomic nucleus and produces a faint flash of light called Cherenkov radiation. That is exactly what the IceCube Neutrino Observatory is. Completed in 2010 at the Amundsen-Scott South Pole Station in Antarctica, IceCube consists of 5,160 digital optical modules embedded in a cubic kilometer of ultra-clear glacial ice between 1,450 and 2,450 meters below the surface. The ice is so optically clear at those depths that it acts as a natural detector medium, capturing the faint blue light produced when a neutrino interaction occurs. Here is what IceCube has found that is genuinely extraordinary. In 2013, IceCube announced the first detection of high-energy astrophysical neutrinos, particles with energies millions of times higher than anything produced in the sun, energies so extreme they can only come from the most violent environments in the universe. These were the first confirmed cosmic neutrinos ever detected, opening an entirely new way of observing the universe. In 2018, IceCube traced a single high-energy neutrino to its source for the first time. The event, catalogued as IceCube 170922A, was tracked back to a blazar called TXS 0506+056, a galaxy about 3.7 billion light-years away, with a supermassive black hole at its center, firing a jet of plasma directly toward Earth. At the same time, Fermi Gamma Ray Space Telescope confirmed the blazar was in an active flaring state, providing the first multi-messenger evidence linking a specific cosmic source to high-energy neutrino production. In 2023, IceCube published results identifying the Milky Way galaxy itself as a diffuse source of high-energy neutrinos. This was a landmark moment. For the first time, scientists detected neutrinos produced within our own galaxy, coming from the plane of the Milky Way where cosmic ray interactions with gas and dust generate a steady background of neutrinos. This confirmed that the Milky Way is not just a backdrop, it is an active particle accelerator on the largest scale. Also in 2023, IceCube provided stronger evidence linking neutrino production to active galactic nuclei, specifically the Seyfert galaxy NGC 1068, one of the closest active galaxies at about 47 million light-years. The detection is statistically significant enough to suggest that the dense environments around actively feeding supermassive black holes are major factories for high-energy cosmic particles. Now the direct question, how are these ghost particles affecting Earth? The honest scientific answer is that neutrinos themselves cause no measurable physical effect on Earth, or on you. They pass through without interaction. But what they carry, information, is affecting our understanding of Earth's interior. A technique called neutrino tomography uses the slight absorption of very high-energy neutrinos passing through the Earth to map its internal density structure, probing the core, mantle, and crust in ways seismology alone cannot achieve. And on a civilizational scale, understanding cosmic rays and the processes that accelerate particles to extreme energies helps us model the radiation environment that spacecraft and astronauts experience, and potentially the long-term radiation history of Earth's atmosphere. IceCube is currently undergoing a major upgrade called IceCube Gen 2, which will expand the detector volume by a factor of 8, dramatically improving sensitivity and angular resolution. That upgrade will allow scientists to pinpoint more sources, measure more spectra, and push neutrino astronomy into a true precision science. The ghost particles are not affecting your body, but they are revolutionizing astronomy. Follow for more frontier science, explained without the jargon. And tell me, the fact that trillions of neutrinos from a galaxy 3.7 billion light-years away pass through Earth every day, does that make the universe feel larger to you or closer?